Today we're going to have some fun with math in a lesson I call Shaking Hands, Stairs, and the Sum of an Arithmetic Series by me, Gwen Fisher. I illustrated this presentation with Doceri software, which is the premier software suite for handwritten and hand-drawn presentations designed specifically for teachers. So I want you to imagine that you're at a party. That's you. You're a little red circle. And you're there with 5 other guests. And here are all 6 of you in a line. And I want you to imagine that each person gives one gift to every other person at the party. So here you are handing out gifts to all the other people at the party, and then you get back in line again so that you can get gifts from the other people. Now the question is how many gifts are exchanged in total? And in particular, you give 5 gifts. Then the orange person goes and hands out gifts to everybody and gets back in line, and they give 5 gifts. And then the yellow person gives 5 gifts, the green person gives 5 gifts, the blue person gives 5 gifts, and the purple person gives 5 gifts. And we can see in total there are 6 sets of 5 gifts, and since 6 times 5 is 30, there's a total of 30 gifts exchanged. Now let's change the problem to something a little different, handshakes. So there are 6 people in a room and everybody shakes everybody else's hands. How many handshakes happen in total? Now this problem is very similar to the last problem, but it differs in that when you give a handshake to somebody, they're also giving it to you. Whereas when you give somebody a gift, that's not the same as them giving you a gift. So there are half as many handshakes as there are gifts. So the number of handshakes is 6 times 5 over 2, which is 15. If we want to do the problem the long way, we can imagine all 6 people in a line, and you're the red person, and you go and shake everybody's hands. That's 5 handshakes, but you don't get back in line because you don't need to shake anybody's hand again. And then the orange person shakes 4 hands, the yellow shakes 3, the green shakes 2, and the blue person shakes 1. And if we add all those numbers up, we get 15, which is the same answer that we got when we did the problem the short way. We can model the handshakes as diagonals of a polygon. So if we have the 6 people standing around in a circle, or in this case a hexagon, then we can model the handshakes by drawing in the diagonals, or also the edges, of the polygon. So the red person goes, when they shake everybody's hands, we see that there are 5 diagonals that we've drawn in for the polygon. And then the orange person shakes 4 hands, the yellow shakes 3, the green shakes 2, and the blue one shakes 1, for a total of 15 handshakes. Now we don't have to orient all of the people in that particular configuration, so here's another way that we could draw out the picture. And in both cases, this is called a complete graph on 6 points, and it shows the 15 handshakes for the 6 people. Now let's look at a slightly different problem. So imagine we have a staircase with 100 stairs, and we want to know how many squares does it take to build the staircase with 100 stairs. And by squares, I mean these pink squares that I'm drawing in here for the first 5 stairs. So we have 1 square for the first stair, 2 for the second, 3 squares for the third, and 4 for the fourth, and so on. But I'm just going to draw out the staircase for the first 5 stairs, because drawing out 100 stairs would take a lot of work. So we want to add all these numbers up, and we're going to call that S. S is the number of squares. We can also write S in the reverse order as 5 plus 4 plus 3 plus 2 plus 1, and that corresponds to drawing the staircase upside down like I've done here. Now one thing to notice here is that when we have these 2 sets of staircases, they fit together perfectly into a rectangle. And the rectangle is 6 units high, and that 6 corresponds to 5 plus 1, or 4 plus 2, or 3 plus 3, 2 plus 4, or 1 plus 5. And so if we add all of those 6's up, we're going to get twice the number of squares that we want, or 2s. Now the width of the rectangle is 5, and that's the 5 set of 6's. And since 5 times 6 is 2s, or 5 times 6 over 2 is s. So what we found here is that 1 plus 2 plus 3 plus 4 plus 5 is 5 times 6 over 2. Now we want to be able to generalize this to 100 stairs, so we have to figure out how the 5 on the left side of this equation corresponds to the 5 on the right. And so we can rewrite the right side of the equation like this, 5 times 5 plus 1 over 2. And then that tells us how to do it for 100. So if we want to add up the first 100 numbers, we get 100 times 101 over 2, which happens to be 5,050. And so what we found is that it takes 5,050 squares to build a staircase 100 stairs high. Now let's generalize this problem to n stairs. So here I am drawing the staircase with n stairs. It's n squares high and n squares tall. And then I'm going to draw the upside down staircase with the stairs in the opposite order. And so we can see that we get a rectangle that has a height of n plus 1 and a base of n. And so the sum of the arithmetic series 1 plus 2 plus 3 all the way up to n is n times n plus 1 over 2, because we're taking the area of the rectangle and we're dividing by the number of staircases. We can rewrite this formula as the sum k equals 1 to n of k equal to n times n plus 1 over 2. This is called sigma notation. And now for the big finish. What we found is that for n people, stairs, or corners of a polygon, n times n plus 1 over 2 is the number of handshakes, squares, or diagonals of the polygon. It turns out it's all the same problem, or at least it's all the same answer. I want to end with two final problems. The first one is to find the sum of the even numbers up to 100. And if you want a real challenger, try to find the sum from 50 to 100 of all of the multiples of 5. So thank you and good luck. Bye.